Hello students, in the previous lectures we had discussed how to find the limit of function at a point and concluded that at some point we can find the left limit of a function, we can find the right limit of function, and the left limit of function may exist, right limit of function may exist, and left limit of function may not exist, right limit may exist, and left limit may exist, and that is finite, and right limit exists, and that is finite, and both the limits are different, and both the limits are same. Now we'll continue the concept of limit at a point at which the left limit of function at a point exists and right limit of function point exists, and to continue with the value function at that point that will give us the continuity of function at the point. So now we'll discuss the continuity of function at a point. For that, let us define continuity of function at a point and compare it with the limit of function in the neighborhood point. And we'll just note down the change in the definition and continue with the change for the continuity of function at a point, and then we'll discuss the continuity of the function in an interval. Now let's define continuity of a function at a point. A function fx is said to be continuous at a point x equal to a. That is, if limit x equals to a of fx equal to fa, this will hold true if given epsilon greater than 0, however small, there is a positive number delta depending on the epsilon, such that fx minus fa is less than epsilon for x minus less than delta. So if I compare it with the definition of the limit of function in the neighborhood point, fa was replaced by the limit of the function, and we discussed it in the deleted neighborhood point. So this less than sign is removed from here, and L is replaced by fa. So this is the only two change. Means the continuity is discussed at a point and limit was discussed in the neighborhood point. So this is the same thing. Means this is a domain at which this inequality holds true. So means what is this domain? This inequality holds true fx minus fa modulus less than epsilon for x belonging from a minus delta to a minus delta open to a close union a close to a plus delta. If we take x belong from this, x belong from a minus delta to a close, a minus delta open to a plus close, and given epsilon is there, how small delta is real number, if there is real number delta given epsilon such that this inequality holds in this interval. So this is called left continuity at x equal to a, and if we take x from this, then we get right continuity of function at a. The left continuity function at a and right continuity depends upon only upon this domain. If x from this, left continuity at a, if x from this, and this equal to holds true, and given epsilon there, and we can find relation delta and epsilon, then get the left continuity and right continuity at a point. Now, if function is not continuous at a point, then the function is said to be discontinuous at that point. So the discontinuity of function at a point is are of many types. This means if limit x is to a of fx, this is limit of function at in the neighborhood point a. If the limit of function in the neighborhood point a is not equal to the value of function at that point, then the function is said to be discontinuous at that point. Discontinuous at that point, or if function is not defined at a. Function defined at a, limit exists at that point, but not equal to value of function at that point, or the value of function at that point does not exist, then the function is said to be discontinuous at x equal to a. And if left limit as x equals to a does not exist, right limit as x equals to a of f does not exist, left limit as x equals to a from negative, right limit as x from positive, both does not exist, both exist and they are not equal. If then limit x to a does not exist. For the limit In the neighborhood point to exist means left limit at a point exists, right limit at a point exists, and both must be equal. So there are possibilities, different possibilities for which the function is not discontinuous. Function is not continuous at a point means function is discontinuous at a point. So we have classified this discontinuity in different kind of discontinuities. First is removable discontinuity. A function fx is said to have removable discontinuity at x equal to a if either fx is not defined at a, or if fx is defined at x equal to a, then limit x approaches to a of fx is not equal to f. Why this removable discontinuity? This kind of discontinuity at x equal to is can be removed by defining fa in such a manner that limit of function at the neighborhood point is equal to value function at the point. Removed by by giving suitable value to the fa. So that's why this is called removable discontinuity. Ordinary or first kind of discontinuity. If left limit of function at x approaches to a and right limit of function at x approaches to a both exist and both are not equal, then this kind of discontinuity is called first kind or ordinary discontinuity at x equal to a. Discontinuity of second kind. If either left limit of function fx as x approaches to a or the right limit of function of fx as x approaches to a does not exist, then the function set to have or produces discontinuity of second kind. So there are three kind of discontinuity. First discontinuity can be removable. Second is if both the limit x both not equal. Third is if either of the limit does not exist, left limit or right limit does not exist, this is called discontinuity of second kind. Now, continuity of function in an interval. Continuity function interval. So we discuss continuity at a point. Now we'll discuss continuity in an interval. Function fx is said to be function defined in an open interval or closed interval is said to be continuous in that interval if and only if f is continuous at every point of this open interval or every point of this closed interval. Means the function is said to be constant closed interval if it is continuous open interval AB and have left continuity at B and right continuity at A. That function is continuous closed interval. So means if a function is continuous every point between A and B, excluding A and B, then the function is every continuous in the open interval. If function is said to be continuous closed interval, if it is continuous at every point in the open interval AB and have left continuity at B and right continuity at A, then function is said to be continuous in the closed interval. Right? This is continuous interval. So open interval means all the points C can take value from A to B, excluding A, B, and in this case, in the continuity in the closed interval, C can take all values from A to B, including A and B. Continuous at every point. That means if you want to draw the graph of this function in this interval, A and B, we have to exclude A and B, and between A and B, we can draw the graph without lifting the pen or pencil. Similarly, from A to B, we can draw the graph function. If function continues from in the interval closed AB, we can draw the graph function from A to B without lifting the pen. This is a limit definition of continuity. Now, continuous function. If function is continuous in whole of the domain, function is continuous in whole of the domain, then that function is said to be continuous function. Which function is said to be continuous? If function is continuous in whole of its domain of definition. Domain of continuity function, a set of points at which the function is continuous. What is the domain of continuity? The set of points at which the function is continuous is called the domain of continuity of function. Thank you.